I often tell this to people that the fact that LLMs can do what they can is very surprising given that they're only looking at correlations in text. So that's shocking that it's so good at all. But I feel like that's where also the main limitation of these things lie, because they don't quite have a way to grasp or ground all of their understanding in some sort of real world structure. And that's when you see very strange hallucinations.
Welcome to Inside the Algorithm, the show that goes beneath the surface of artificial intelligence into the scientific research, technical breakthroughs, and academic thinking shaping where this technology is actually heading. I'm Jeremy Bradley, Chief AI Officer at Cambridge Spark, a leader in transformational data and AI upskilling, career development, and progression. Each episode, I sit down with the researchers, data scientists, and technical experts working at the true frontier of this field to explore not just what's happening in AI, but also the real science and thinking driving it forward. Whether you're building sophisticated AI systems, leading teams through AI transformation, or driven to understand what's really happening beneath the headlines, this is the show for you. In today's episode, we're examining something that underpins almost every modern AI system, yet rarely gets discussed on its own terms: the reasoning machinery behind the models and why getting that right may matter more than making them bigger. My guest is Dr Vaishak Belle, reader at the School of Informatics at the University of Edinburgh, Alan Turing Institute Faculty Fellow, and Director of Research and Innovation at the Bayes Centre. He spent 16 years at the intersection of logic, probability, and machine learning, and has become one of the clearest voices for a more principled approach to AI, one that goes well beyond scale. In this conversation, we get into why scaling won't necessarily solve hallucination, what the success of tools like Claude Code really tells us about how AI generates working code, and what it means for developers changing roles. I hope you enjoy it. Vaishak, you're really welcome. Thank you so much for joining us.
Thanks, Jeremy, for having me here.
Fantastic. It's really exciting to have you on Inside the Algorithm today, and not least because you've been working at the interface of research in areas around foundations of ethics and explainability, and now generative AI for 16 years or so. So really nice to have your perspective on the podcast. If you had to describe the single biggest shift you've witnessed in that time, not just technically, but in terms of the field itself, what would that be?
Yeah, thanks, Jeremy. I suppose technically maybe the answer is obvious to some extent. It's the Gen AI growth. But I would say sociologically, a big shift has been sort of the humility. So, people say that during the first AI boom in the 80s, there was a lot of enthusiasm and promises and guarantees of success. And I feel like this has come back right now. So to a large extent, before we saw the Gen AI bubble, we knew certain problems were hard. So, for instance, classical search, where you look through a tree and try to find a branch that's useful to you, is often intractable under some conditions. So we knew computation was a big challenge here. What changed, however, with Gen AI to some extent is that, there's the impression that, a large chunk of human common sense knowledge is accessible, readily available. You can go in there, manipulate things. And with that, I think, the humility has gone away a little bit. I'm not saying it's not warranted in all cases, but it does feel like, people promise, the world to you. But there's a risk where we don't really know when and how these systems fail, and that can come back to us in a very serious way.
That's a very interesting statement, and certainly, I think what I see myself is that people see a certain level of capability, and then they infer a much grander set of capabilities from whether it's large language models or agents or anything that's sort of derived from that technology. I mean, it's undoubtedly incredibly impressive technology that will, I'm sure, attract a lot of prizes and plaudits and in the future. But it's still in development, and there's still things that it needs to work on. I think it's fair to say.
Yeah, I mean, most interestingly, humans, when they often make statements, they have a sort of world model in mind, right? So, for instance, if you were to ask me, what's the weather going to be like in Edinburgh tomorrow? I'm basing it on some data, of course, the number of years I've lived in Edinburgh. But also, I look out of the window, get a sense of the sunshine and so on, and make a judgment. And with the LLMs, it's often the case that it's a completely linguistic correlation. So we know, for instance, often when people say it's cloudy, we expect rain. If it's sunny, we expect warm weather. So it looks at these correlations and utters things based on that. So to a large extent, it seems, and this is very surprising. I often tell this to people that the fact that LLMs can do what they can is very surprising given that they're only looking at correlations in text. So that's shocking that it's so good at all. But I feel like that's where also the main limitation of these things lie, because they don't quite have a way to grasp or ground all of their understanding in some sort of real world structure. And that's when you see very strange hallucinations. A classic example is there was a viral meme going around where they asked a large language model, I have a car, I have to get my car washed, which is 50 meters away. What's the better thing to drive there or walk there? And many large language models, even frontier models, said just walk there. But of course, without my car, what's the point of going to a car wash? That kind of thing. So it's very surprising where it fails and also impressive when it works,
Just to give yourself an opportunity to talk about your perspective, your work sits at the intersection of logic and probability and machine learning. For the audience who maybe assumes that those are slightly different fields, how have you bridged those, and how has that become a sort of logical pathway for your work and research?
Yeah, that's a very interesting question, because to some extent, I feel like the history of the field is reflected in the way these areas have come together. So if you think about, what we're really trying to do in AI, we're trying to target the question, how do we get the behavior of a system correct when we don't know much about the world? So in a way, you can see why it's inspired by cognitive science. It's inspired by psychology, obviously human intellect, which is where it starts from, going back to Alan Turing. So in a way, logic and probability are capturing different aspects of the way we look at the world. So, one way to look at the world is to see the objects in it and the relationships they have. So a glass of water sitting on my table, if I push it, it would, spill the water all on the table. That's the relationship aspect, and there's a logical and algebraic flavor to that. But on the other side, going back to my example about rain and sunshine, if you map the weather in Edinburgh across many years, you get a sense of the distribution. What can we say about the weather in June? What can we say about the weather in July? And so there is a data aspect to it. And a part of this intersection of looking at logic and probability is to say, what's the best way to look at the world in a joint and coherent fashion that captures the relationships and the statistics. And that's kind of where, I got started, because I sort of thought, it certainly makes sense that there are certain aspects of the world that are logical, and there are certain aspects that are statistical, and we need to look at the ways that these things combine. The latest iteration of this is something called neurosymbolic AI, where the statistical aspect is completely built by a deep learning system. It's broadly we could call this hybrid AI. It's a very broad term, and maybe intentionally so, because what we really think is not the dogmatic definition of keeping feel separate, but thinking about what problems arise in this context for us to behave and act intelligently, and what do we need to make it work, right? So it's not, I'm not often surprised to see philosophers and cognitive scientists also at our conferences, because it's a question that interests all of us.
I think so. And judging by, so I was really interested to see you presented a talk at I think recently in Sweden in March in the Wallenberg Advanced Scientific Forum on neurosymbolic AI, and that was a title I thought that really sort of pulled me in and made me start thinking about the reality of trying to get these two worlds to interact, the world of the statistical language model and the world of the sort of reasoning, the logical, deductive, planning, rich model, if you like, that ironically I think has been was the foundation of AI sort of for over 30, 40 years. That's where the field has come from, and only relatively recently has it moved into this sort of more probabilistic area. So I'd love to know then from your perspective, sort of what neurosymbolic AI is, just first of all, and what you feel its value is, and what problems it can really tackle that maybe sort of the two separate worlds would struggle to.
Yeah, thanks, Jeremy. I'll say a bit about this Sweden talk, because maybe it connects to what people have been thinking about for the last few years, which is large language models. And again, as we both discussed, these are very impressive, do amazing things. But if you look at the GPT-4 or pre-GPT-4 era, what you often see is when you ask these GPTs for calculations, for instance, what does your mortgage look like in 5 years? It often would make up numbers. So what changed then is that many of these systems, from OpenAI's ChatGPT to Anthropic's Claude, they started taking this approach where they would take your natural language, they would kind of parse it, and they would often produce a Python script or an algebraic equation that captured the mathematics. And suddenly you started getting answers that made sense, including combinatorial problems like, you have a bag of 6 oranges, how many different ways can I arrange them? Such that, when I pick 6 oranges and 4 apples, how can I arrange them? Or what do I get if I pick one at random, and so on? So there's an algebraic, substrate now for many of these systems, and suddenly they started becoming more reliable. And that to me is sort of the key manifestation of this neurosymbolic AI, where we're using large language models purely as a textual understanding and parsing unit. But we understand very well that this sits in a sort of a hierarchy where, as a cognitive function, we have to get agents to plan. So maybe you're interested in taking a holiday to Hawaii, and it doesn't, it's not enough to know what people have done before. You have bespoke constraints. You say, I want to go in July and come back in August. I want to find a place where my kids can go to. So all of these constraints start fitting in. And that's when you see this neurosymbolic split, where there's some bit which is purely neural, and it's done very well using deep learning or large language models. But there is a bottom unit where this kind of manipulation takes place. We move things around and get to answers. And this, is a sort of interesting, going back to human cognition. So in the 1600s, bizarrely, Leibniz, postulated that maybe human thinking is a kind of algebraic system. Maybe we can come up with a calculus for thought. And the question is, can we arrive at that calculus? Because we know there is likely no place in the human brains where we store symbols. And yet certain things we do have a very symbolic aspect to them. So we could really think of symbols as sort of abstraction for thought. How do pieces come together? How do we compose? How do we build hierarchies, right? Not surprisingly, a lot of this is happening inside our brains in a very complicated way that we can't quite work out evolution is giving us a lot of help here. But if we are to implement a system that kind of captures that complexity and nuance, we need to come up with the best architectural choices that reflect that. So one position, of course, is to say, train a neural network, throw more data at it, see what happens. And to some extent, it works to a large extent because it can pick up on the patterns in our real world. But there are places where it breaks down, like the car example we talked about. So this is a place where keeping sort of an abstract way to think about our thoughts and composing them makes sense. One thing we got interested in recently was the so-called theory of mind problem. So this is a problem that comes up, or this area comes up, in philosophy. It also comes up in game theory, cryptography. And the key idea is, imagine now we have a bunch of distinct agents. In this case, there are two of us talking, and we both have ideas about the world, right? So, you live in a certain part of the country, you have certain ideas and local knowledge, and so do I. And if you're trying to communicate, so for instance, if you say, would you like to come over to where I live? You might give me some logistical pieces of information, and we share this information. So we're communicating. So theory of mind turns out to be the key component of our social and explanatory dimension of us as agents operating in the world. Right. This is how we communicate. We make sure we don't crash into each other when we drive cars. So we try to think about what would it mean for the theory of mind to be somehow present or emergent in large language models. And what we discovered is that, to some extent, it can pick up, if you say things like, oh, Jeremy told Vaishak that, he's going away on a holiday next month, I can work out certain things from that. But as you get deeper and deeper, so if you ask, what does Vaishak think about Jeremy's preferences, or, how does Vaishak know that Jeremy likes to go here and not there? It starts getting more and more complicated for the large language model. And again, the reason this is happening is because it's picking up on correlations. So the approach we took was to come up with a sort of algebraic approach for capturing the theory of mind. So the language model understands the context, gives us the algebraic expressions. We solve this, using a solver, and we feed it back to the LLM, and it ends up doing the right thing.
I hope you're finding this conversation as fascinating as I am. If you're getting value from the research and technical depth we dig into on Inside the Algorithm, please take a moment to follow the show and leave us a review on Apple Podcasts, Spotify, or YouTube. Every follow helps us reach more of the brilliant minds doing this work and keeping the rigorous, substantive conversations going. You can find Inside the Algorithm on the Data and AI Mastery podcast feed, or watch it on the Cambridge Spark YouTube channel. You will find the links to those in the show notes below. Right, let's get back into it. I love the idea that your description of ChatGPT, essentially it's spotting that there's a problem to be solved in a particular domain. It's identifying that domain. It's then finding the technical solver, if you like, the technical tool that maybe best solves that particular type of problem, and then invoking it, calling it, structuring the problem so it can be solved that way. I think for a lot of people, that's going to be quite surprising, because I think people imagine that the technical expert in whatever fields that they were coming from would be the person who understands when a problem is of a particular sort and what the best solution approach is for a particular problem. I'm not necessarily talking about that in academia, but obviously it applies there. But in general, in a planner, a pricer in a company, even someone who just is a market analyst, they will have a set of instinctive tools at their fingertips, and they will go to those tools in order to solve a problem. And what you're saying is, here's a version of an AI tool with a large language model where it will also have an understanding of the world, which allows it to pick the right tool, maybe of several. But not only that, it can take into account the person who's asking. It can take into account maybe the preferences, and it can take into account the perspective and maybe some logistics around around what it would mean to solve that problem of getting the car to the car wash, for instance, or going to the shop to get groceries, and what's reasonable and not reasonable in those circumstances. I think that sounds to me like a really an extraordinary step forward for the field. Is that how it's recognized?
Well, yeah, I mean, to an extent, theory of mind is a question that from a psychologist to computer scientist to roboticist have been thinking a lot about, because as you can imagine, in many of these care home robots and other kinds of systems where you have rich social interaction, you have to be very mindful of what the intent of the user is. So, if you imagine, speaking to a robot in a mall, and it keeps asking your name every couple of seconds, you're going to get annoyed with it very quickly, right? So keeping that user intent in mind is a concern that they've had for a long time. I think, what my sense is that the way they've tackled this has been sort of ad hoc, where they've tried to keep a very simple model for the user intent. And I suspect as we get into more and more complex applications of LLMs, certainly when you go into agentic AI, we may want to think more carefully about what it is that the user is intending to do. Again, it's not so easy to extract this information, right? So if I just gave you a questionnaire of 100 questions and asked you everything, you're going to have a sort of a sense of frustration by the third or the fourth question. So to elicit this information and this preference can't simply be me asking you 100 questions. It has to be interactive. So I would say there's a lot of human-computer interaction questions to be worked on at how we arrive at that. But at the bottom, it does feel like keeping a good model for what it is the person that I'm speaking to is interested in is going to make this interaction much more meaningful.
And do you think this is going to be a way of sort of getting to grips with what people call hallucination? Because, I mean, I think, you and I both know hallucination isn't really hallucination. It's just the model selecting what's most probabilistically likely. It just happens to be either demonstrably wrong or silly or just not appropriate for what we happen to know in our sort of logical world, but it's still doing what it's coded to do. So it's not actually making things up. So do you think that this model is going to be something that then helps to get on top of that challenge, or is that going to always be a challenge for language models?
Yeah, that's a sort of a very sort of a hard question to answer, because as you say, it's not a hallucination in the sense of, I'm not imagining an alternate world where I live in the Lord of the Rings or in the Marvel universe, but it's really what people are calling confabulation. And mainly what's happening is that it's looking at, again, correlations, and some correlations are less likely than others. So an example is this, as I said, pre-GPT-4, when you asked it math questions, it would often give you nonsensical numbers, mainly because it saw these groups of numbers appearing with the latter group somewhere else in its training data, and it's just producing that. Now, what's happening with the hallucination problem is that obviously with bigger and bigger data and this kind of neurosymbolic split we are seeing in Claude Code, where the language model is producing a Python script that does the computation for you, what we're seeing is that kind of numeric confabulation is becoming less and less likely, because now they have a very good delegation module within these systems that makes sure that if you ask for mortgage calculations or stock prices, it goes to the appropriate module and gives it back. So I think that coverage of the training distribution is getting more and more dense. So it could be that, hallucination or confabulation, as we think of it for many factual points, may become less and less likely as you get to larger and larger numbers. But that doesn't quite, get rid of the problem that it's only relying on the training data. So in some cases, you might extrapolate your question in a way that's not there anywhere in the training data, and the only thing you can get are the likely outcomes from the training data, right? So I don't have a very good example for this, but maybe the car example is one such thing. You could genuinely imagine, you could say, I'm expecting an asteroid to fall to Earth, and maybe there's no training data on that. What do you expect people to do? And because it has no training context for this, it could give you something completely nonsensical. And the trouble is, we don't know when it does this versus when it can confidently say the next likely outcome makes sense given its training data, right? So that's where the risk point is. That's the pinch point. So in a way, this kind of approach of finding a relationship between the language part and some sort of mathematical component that verifies or understands what is being said could be a way to get out of the training problem, of the hallucination problem, right? So in fact, you might be familiar that people have tried out things like these retrieval augmented graphs. And what these things do is that they provide a large context in the prompt. This might be relationship triples. It might say, Obama is the president of the United States from this year to that year, and it uses that information to get to its answers. So that could be an approach, but I would still say, because it's working on correlations, there's always a risk that what you get out of it is plausible, but not what you're looking for, and maybe even wrong.
And yes, indeed. In that, I think we all may be accused rightly of being wrong at some point. And I wonder how much actually we're trying to sort of perfect something which is not perfectible, because human beings will often jump to that kind of correlatory linkage and then try and post-rationalize it almost. I think
there's a big risk there. I mean, as you say, it's so easy to make that comparison to the fallibility that humans exhibit, but they are distinct, right? So for instance, let's say, you know me as a person who borrows money but never gives it back. And if I ask you, Jeremy, do you have any money in your wallet? You'd lie to me and say, no, I don't. But again, there's intent there, right? Whereas with large language models, there is no intent. So even if it changes its response, it's completely prompt sensitive. So you can't rely on that. That makes it very dangerous.
In that that's a really good example. In that example, I've invoked something from another bit of machine learning. I've invoked essentially a piece of reinforcement learning, which is that over time I've learned that if I lend you money, which, to be clear, I haven't, but it hasn't necessarily come back very quickly, and so I've associated in reinforcement learning terms, I've associated a negative reward with that action. So I'm taking into account my context that's been learnt over time. So now I've got a temporal relationship here with that action. Do we see one of the sort of developments with large language models and indeed AI sort of agents in general as incorporating that kind of reinforcement approach and that kind of learnt reward in its development to enable it to know essentially which tool should I reach to have the best impact, or I know that if I go down that road, it doesn't work out very well, so I'm not going to do that again.
No, I agree. That's so reinforcement learning, as you know, has been a very active area of research in machine learning for a long time. And certainly the inspiration for this is exactly what you say, the behavioral aspects of intelligence, where you provide rewards or punishments as mechanisms to enforce the right behavior. And to some extent, many of these, large language model based chat agents do have some sort of reinforcement built into the training. So an example is I don't know if it's still possible now, but a year 1 or 2 years before, people could say Jeremy is the leading expert in quantum AI, and if you keep putting that into ChatGPT multiple times, at some point if somebody says unknown to you, somebody says who's the expert in quantum AI, and your name would come up, right? So I don't think it's possible anymore to do this, but I think this kind of reinforcement learning is an approach to improve its behavior. And perhaps one place we have seen, I would say, a magnificent improvement in its performance is in terms of code. And the reason we see that is a bit surprising, because if you think about code, it's very structured, right? There's certain things that work and certain things are syntactically impossible. So what's working with code and Claude Code and Codex and all of these tools is that there is a clear sense of evaluating an output to be correct or wrong, right? So if you ask me to give you a poem, I can write something for you, and you could look at it and say, this is rubbish, but I could come back to you and say, no, actually, it's quite good because it has this wordplay. So there's a lot of ambiguity in how we judge whether a textual output is good or bad. Likewise, if you ask me an essay about Winston Churchill, I could produce something that looks very dry, and you could say this is so dry, but I could say this is exactly what we need. We need a factual output. But with the coding, because you have, especially if it's trained on GitHub, you have, all the change and the commits inside the file history. You have a clear sense of this function. Sometimes a function name and the signature is very instructive. All of these are signals, right? So if you take those signals and feed it back, some of these pre-trained models produce amazingly good code. I'm not saying it's perfect, because often it may not be catching things that an expert programmer would catch. A good example is if there's a security flaw that's easy to pick out, maybe it can't work it out because none of the test functions it builds catches that. But an expert programmer might say, this is actually very insecure because it's storing everybody's password as a text file. Simple as that, right? But again, because it's trained on so much of GitHub and other open code repositories, it's possible that it's producing very good code.
Yeah, but the coding thing's a really good analogy, and certainly when it started doing that, it was almost a bit of a mystery, because even I think you said this the last time we talked, even a semicolon in the wrong place or a comma in the wrong place completely destroys the semantic sort of logic and meaning of the program. And yet, whereas if you slightly position an adjective out of place, or put move a verb around even within reason, it doesn't at all. You've got the same meaning, and people might go, oh, that's quite a nice innovative way of structuring that sentence. It might be more poetic that way, that kind of thing.
So I suppose it's in a way producing nonsensical or syntactically incorrect code is easy to catch. And as you say, with natural language, that's not the case. So the signals, again, reinforce this point.
So, right. So do we envisage that then probably these tools are applying some sort of post hoc syntax checker just to make sure that the code it's suggesting is going to compile, basically, or at least parse. So certainly in terms of the output, is that what's likely going on in that case?
That and many other things. So with Claude Code, for instance, as you know, the Claude Code's skills was accidentally released by Anthropic a few weeks ago or a few months ago. I can't remember. But one of the things is that there are lots of permission checks within the code, right? So So it's almost that it's creating a technical solution to human oversight. So if I wanted to execute a piece of code on your computer, you might say, first review the code by me, check the folder it's working on. And Claude Code has a lot of these permission checks within it that's mimicking this kind of oversight. And that's the reason that they turn out to be better and better. And again, let's not forget the fact that, the amount of investment that goes into engineering these systems is massive, right? I mean, it's about the GDP of a few small countries. So it's not surprising, and they have very clever people working in these companies. So it's not surprising that it's doing so many things well. So I suspect, again, I don't quite buy the hype that it's going to replace software engineers, but I certainly think just like we had, ways to call somebody else's code previously in programming, now we have ways to call signatures, right? So I can just say, write me a function that's going to extract this podcast transcript, give me the bullet points, and send an email to all my colleagues, right? That's quite easy to do. And it's probably going to be able to do that.
It's, and just you talk about Claude, and obviously they've had lots of publicity around Mythos and Fable of late. But for the brief period of time that Fable was accessible to outside of the US, I heard in very interesting conversations around from the coding community and from the software community saying, I gave it my hardest problem, the thing that would be really stumping me for, weeks, months, and it worked through the code and it sorted it out. And in the 2 or 3 cases I heard the details on that, it very much sounded like something was going on, which is analogous to what you're talking about in the neurosymbolic world, which is that it felt to me like it was actually doing some kind of dynamic sort of pathway analysis in the code to find specific values of variables or strings or inputs that would trigger issues, security flaws, bugs emerging, which just by looking at the overall sort of static sort of map of the code, it probably wouldn't have spotted, or it would have been very difficult for a human to spot as well. So I that's my hypothesis. I have no evidence that that's what it was doing, but I wondered that, whether we're basically seeing them augmenting these amazing tools with a lot of the sort of behind the scenes, smart solver technology that we've been working on also actually for a number of years.
Yeah. No, absolutely. And the other thing is, as you say, the pipeline or even the orchestration of producing code and checking for it has so many things that an expert programmer would watch out for. And what they've done is they've engineered those things into it. So I in fact, this morning, I got an email to say that Fable is going to be temporarily open to everybody. I think from now on, not Mythos, but Fable is. And one of the things it says in that email is that, the things where you say check your work is no longer necessary, because there's a couple of while loops sitting there which says, whatever you produce, cross-check the outcome, evaluate it back, and then only run it. See what it's changing in your file system and come back to it. So those guardrails have been engineered in, and so if you think about that, that is amazing, right? It's like you could imagine somebody working at Microsoft or Google for about 15 years to have all of this insight into how to check code, but any introductory programmer wouldn't have that. There's no textbook that would tell you what to watch out for, and now all of that has gone into these models, which is why I think there is so much excitement. I mean, to some extent, a lot of hype as well, but there's so much excitement about them being these robust, but I don't think the robust is quite the right word, but inventive programmers, right? And it makes sense. I mean, and I certainly see that trend possibly growing a little bit. The question is, at which point are we going to get code that kind of makes sense, but has a huge amount of security flaws, and whether reinforcement learning can fix those security flaws too? That I'm not so sure about.
And another matter for one profession, which is the future, the future, if you like, of the developer, the software engineer, the coder, because if the tools are embedding a lot of that good practice sort of software patterns and software development process in terms of constraint checking, output checking, validation, testing, even documentation, and all of the good things that we used to really try and drum into our development teams. What's the role of the programmer and the software engineer in the near future? And is it one of orchestrator or manager? What how do you see that playing out?
Yeah, good question. I honestly don't know. I mean, I think we are running the risk that we are not giving an opportunity to the younger programmers to learn the skills of the trade. So, senior people might really bootstrap their productivity to some extent with these tools, but a junior programmer is going to struggle. And there's risks also from a psychological point of view. So you might be well aware, if you run Claude Code or one of these tools for a few times and you see everything is making sense, you stop checking, right? You just have this sort of cognitive dissociation because you're exhausted by just clicking approve all the time. So it really becomes an opportunity to rubber stamp things that look kind of right, but you haven't bothered to check. And if this happens a lot, we're going to see huge issues in the kind of the quality of the software coming out there. And I suspect it's already happening now. I mean, now every time, Windows systems crashes or a browser crashes, I often see tweets on the social media saying, this is an outcome of wipe coding inside Microsoft. I don't know if it's true, but this is what people like to complain about, and we might see more of that, right? So I think there's a risk there.
I 100% agree with what you say about junior software engineers, junior programmers, and indeed juniors in general in a lot of these technical areas. I think finding the right pathway for that upskilling from new to the field to respected senior and subject matter expert is going to be so important. It may be different, but I think it's going to be so important. So I've got one final question for you then, Vaishak, just as a quick fire one, if you like. Just alluding to what you said there, actually, for someone who's a bit earlier in their technical career who wants to think seriously about AI from this sort of foundational perspective, rather than just sort of what's the next model that's coming out, what would you say they should get excited about, get interested in? Where would you point them?
Great question. I mean, obviously, every undergrad is thinking about these questions. And what I would say from a practical point of view, you can't quite completely ignore what the kind of hype right now. So if there is hype around agentic or whatever, it's useful to know a little bit. But I would say if you're forward thinking and you're looking after your passions, it makes sense to then think about, again, if you're approaching it from the point of view of being interested in AI, go back to the discussions we had around, cognitive science, cognitive function. What does it mean to have intelligent behavior? How do we characterize it? And if you see the history of AI, there's a complex and rich field going to mathematics, game theory, cryptography, agent-based modeling, multi-agent systems, robotics. And, there's so much variety there that, you don't have to, pigeonhole yourself to one area. And most likely we'll see a deeper integration of these as we go forward, including, theory of mind and interoperability across systems. So it's useful to keep that perspective and to think about, if we don't buy into the idea that all jobs will be made redundant, and I don't think it's going to be that case, and I certainly hope people are not pushing towards that, then what's the thing that would, solve problems for society? And maybe that's when they need to look.
Nice. Well, that's a lovely positive note to end on, Vaishak, and I think one that will hopefully inspire and encourage a lot of people to really get into the field and see it as a positive thing to execute in. Thank you so much for joining us today. I've really enjoyed the conversation. It's been great.
Thanks so much, Jeremy.
Thank you for listening to this episode of Inside the Algorithm. If today's conversation gave you something to think about, make sure you subscribe so you never miss a breakthrough, and share it with someone who'd appreciate the thinking. If you're a data and AI leader looking to build deep technical capability across your organization, Cambridge Spark is here to help. You can reach us on LinkedIn or at cambridgespark.com. And if you want to explore AI from the leadership and strategy perspective, check out our flagship show, Data and AI Mastery, with Dr. Raul Gabriel Irma. Until next time, stay curious, stay rigorous, and stay ahead of the algorithm.